Hey, what's going on, guys? Kings here. Last video we implemented board variables and board related variables and some helper variables as well. So this time we already have everything in order to actually print the board to screen. So assuming the bitboard implementation, we have up to 12 integers, unsigned long integers, also known as bitboards, representing some sort of a possible availability of pieces on board. So our goal now is actually to map all these 12-bit boards together and print actually this like chessboard to make sure that all the pieces, so to make sure that if there is any piece on whatever bit board, make sure this piece would be represented on our board that was supposed to be printed to the console. So this is kind of it. And also obviously would be printing the side to move, the enpassant square, and castling rights. So all these board state variables as well. So let's actually go to input and output section right over here, and just below the print bit board I would like to start implementing our print board function here. So obviously we would also go for initializing our bit boards with some sort of a pieces to actually check whether this print board function works or not, but I will now just start implementing it, and then I'll go to initializing a couple of bit boards just to give you an idea of how it works basically. So let's create the void function called print board, and as far as we have all our board related variables and the bit boards as the global variables, we can enjoy an empty we can enjoy a no arguments function here, function definition, and function call in future as well. So this is kind of it. Well, let's actually start. The very first thing to do, we need to loop over the board ranks and false. So let's start. So loop over board ranks, and here I just say for int rank equals to 0, rank is less than 8, and rank plus plus. And now the same for the false. So we need to loop over board false. So just the same, but with the fall here. Fall, okay. And now I want to initialize the square variable. So int square would be equal rank multiplied by 8, because this is the width of our chessboard, and plus fall. And here we want to print new line every rank. Okay, so just printf new line like this. And here I just want to initialize not initialize, but define piece variable. So let's say integer piece would be equal to -1, because we have our piece encoding starting from 0 and ending up with 11, right, for the black king, or is it? Yeah, it should be. So here we'll try to provide some logic to actually reference the all the bit boards within the loop, but before that I just want to print the following stuff. So let's start with the character first. I will later on make it different for Windows and for Linux to print ASCII characters for Windows and Unicode characters for Linux. But first I just want to say, so piece equals -1, and the ternary operator here, and if it's true, in this case just to print a dot here, otherwise let's print, I don't know, it doesn't matter. So so we would be printing the actual piece. So let's say, okay, we can define this already. So ASCII pieces indexed by the piece, like this. But we're not gonna fall right in here for now, because the piece for now would always be -1. So I just want, so let's clear this stuff from the previous part. Well, we can leave some bitboard definitions actually from the previous part, and I just want to print chessboard here. So print board, and it should be printing an empty board at the moment, with dots representing an empty square. So let's open the terminal in the current working directory, and by typing make debug I want to build the sources, and if it compiles I want to run the BBC binary executable. Okay, perfect. So here we have our chessboard placeholder. So now let's prettify this slightly a little bit. I don't want this bitboards for now, even though I will uncomment that later on. So for now, let's go to our print board function. So here I want to print ranks, so I can say if not file, which means if the file is equal to 0 actually. I just want to printf and the decimal specifier, and this would be rank, 8 minus current rank. So this should work. Okay, we got our ranks. Now let's maybe make a little bit more. So yeah, just to map this with as the same way as we done on the print bitboard. Yeah, so this is it. Okay, and yeah, this seems to be just pretty nice. So here I want to print board files. So printf, and I'm not sure how many new lines, but we'll see. So A, B, C, D, E, F, G, H, and let's have a look. And just want to put this. Okay, so now this is much better. Okay, I'll probably want to print one additional new line at the very beginning of the function call. So let's print a new line here. Okay, that's called is just print offset. Okay, and now let's go for referencing our bitboard. So the idea is very simple. We need to loop over all the bitboards available, and then for every single bitboard we need to ask the question whether there is a bit turned on a current given square or not. And if it is, we just initialize our piece variable, and we'll initialize this with a corresponding piece encoding, and then we'll use this to index either ASCII or Unicode pieces. So it's much easier to demonstrate rather than to explain, so let me show you this quickly. So here we need to loop over all 12 bitboards, or better to say over all piece bitboards. So 4 and integer. Well, let's create a nice name for a bitboard count, or maybe just let's say bitboard count like this. equals to white pawn, so white pawn equals to 0, and bitboard count is less equals than black king, and bitboard count plus plus. So now we want to ask the question. So if, and now we need to reference the bitboards by this bitboard count, or it's better to say even not count but piece. Let's call this bitboard piece, bitboard piece, like this. So bitboard indexed by the bitboard piece, so it might be either white pawn, knight, rook, bishop, and so on, or black pieces, so bitboard piece. So I want to get bit on this bitboard and at the current given square. So we've just initialized our square right over in here, right? So referencing first white pawn bitboard, so if at this sort of a square get bit returns true, this means that there is a piece, otherwise not. So if it returns true, we actually need to say our piece, which is the variable to hold the piece code, would be equal to bitboard piece, which is the counter within this loop over the bitboards. So assuming that we already have the white pawn on e2, in theory it should print us a pawn on e2. Perfect, just perfect. But it now only does this for like in Windows version only, so only the ASCII pieces as ASCII characters, but I also want to make it Unicode codes for Linux. So if I just try to search for this print board again, and here I say so just print different piece set depending depending on operating systems. So we can say if def win64, in this case we want this like stuff, and else we want to print f, and this would already be the, sorry, not like this, string identifier, string formatting identifier, and here the same, piece equals -1. If so, then we want to print the string 1, and otherwise the Unicode pieces and indexed by the piece. So now it should okay, and if at the very end. Now it should print the pawn as Unicode character. Perfect. Okay guys, so this is probably it regarding the board position, but let me just try a couple of tests to make sure it kind of works. So here I'm printing the pawn's bitboard. Probably I shouldn't doing this. So let's try to set some more pieces. So let's try to set the pieces on A2, B2, C2, E2, D2, ABC, sorry, D2, E2, F2, G2, H2, yeah, like this. And it, in theory, it should print all the pawns now. Yeah, perfect. And so set. Obviously, we're not gonna be doing this in production. Let's say it's just a test here. So we'll set. But I just want to test this, obviously. So set white pawns, set white knights, and let's take our knights on b1 and the one on g1 as well. b1 knight. So let's have a look. So now the knight's appearing on the board. Okay, so now let's do the same for other pieces. So say set white bishops. I'm just doing this just to give you an idea how all these bitboards are mapping together. That's it. So bishops, obviously nobody would be doing this, but just for clarity. So c1 and f1. So we got our bishops being set up. Now let's go for rooks. So white knights, white bishops, white rooks, and rook on a1 and h1. Okay, and king and queen. Queen and king. So king and queen. So king would be on e1, queen, or let's start with the queen. Queen on d1, king on e1. Okay, and now let's go for the same. Let's go the same stuff, but for the black pieces already. So pawn. Bishop, rook, queen, king, and 7. Okay, something has gone horribly wrong. Hold on a sec, guys. Oh, actually, this should be 8. Yeah, d8, g8. Yeah, pawns on the 7th rank, and this piece is on the 8th rank. So here we just make sure that our board position looks quite pretty nicely, but also we need to keep track of our board state variables like side to move, in peasant square, and castle in right. So let's go and implement those as well. So let's search for our board position and print board again, and here I want to print side to move and printf side, and I'm not sure regarding the layout. I'll be fine-tuning this right now. So side, let's take this a string here, and let's say, so if white, or that means is 0, oh sorry, if side, if not side, which means this is white actually, then we want to print white, and otherwise black. But at this moment, oh, I'm sorry, ternary operator. Yeah, but at this moment it would be so it's not equal. So side is now equal to -1, which is not really kind of right. So it prints like this is black. Not really that great idea. So well, probably we can just leave the side alone for now. Or yeah, now side equals -1, which it's treating this to be like not white, and hence it considers it to be black. So well, probably we can do the following trick here. We can just alter the condition, I guess, I believe. So let's say not side, and side is not equal to -1, like this. Hold on a sec. Okay, I feel a little bit lost here. So we just don't really need to care about this. That's what I want to say. But as far as I already did initialize this to -1. So okay, let's say initialize the side, and side equals to white. So now it should print white. Okay, if side would be equal to black, it should now print black. And yeah, so the problem that we don't keep track of side equals to -1. We don't really need this. Well, okay guys, so just to make it easier and avoid all these possible disasters, I just leave the side alone, and I just won't be initializing, so by default it would be equal to 0. Okay. So if I'm not doing anything with the side, it would be equal to 0, hence print in whites. Okay. If I say side equals to white, it should be the same, because it's still 0. And if I say side equals to black, it should print that the side is black. Okay, now let's work with this layout slightly a bit. So print board, and okay, and the next thing to consider would be the enpassant squares. So print enpassant square and printf enpassant. Let's call it like this, or I'm just not sure if it fits the width of this stuff. Okay, so it would already be nice to give it square to coordinates kind of representation. So this would be a string, right? Yes, this would be a string. So I need to say enpassant is not equal to no square. So in this case I want to print square to coordinates indexed by the enpassant square, and otherwise I just want to print no, like this. Okay, so let's have a look. Yeah, I just don't really like this layout, so let's limit this slightly. Okay, still. Okay, how did I do this in my engine? Don't even remember. Okay, probably let's make it like this. Okay, and enpassant, and now we just try to initialize our enpassant. So side is equal to black. Okay, so let's drop it back to, well, let's actually make it black. It's fine, black. Initialize enpassant. So equals, let's say it equals E3, and it now should print that, excuse me. Okay guys, sorry, something has gone horribly wrong with my console. Okay, now it prints this enpassant equals to E3, as far as we just did set it up respectively. Okay, and finally we need to get down with our castling rights, so let's go for this as well. So finally here we want to print castling rights, so printf and castling and this would be king, queen, etc. So up to 4. I'm not sure whether I should go for characters or, yeah, exactly. So up to 4. Oh, what have I done? Up to 4 characters and a couple of new lines, and here so we say our castling right bitwise ended with white king castling, white king side castling. If true, I want to print K, otherwise dash. And now for all the other, for all the rest of castling rights, so white castles queen side, like this, and then black castles king side like this, and finally black castles queen side like this. Save. Okay, let's have a look. Okay. Yeah, so it should be right because castling variable is now equals to 0 by default. It's not initialized, and actually I would probably go for just want to prettify the layout a little bit more, or hold on, just I know that doesn't really care that much, but for me these tiny little layout details are extremely important. So now let's actually drop them back. Oh, what have I done? Let me actually maybe just okay, I just want to have a look how it goes in print bitboard actually. Sorry guys, sorry for wasting your time for this, but for me it's incredibly, all this layout stuff is incredibly important. So so it goes like right over in here. Okay, okay, so in this case let's let's probably drop it like this. Okay, I don't really like this kind of collision here, but okay. So now let's try to initialize our castling variables. So initialize castling variable. So if we just say castling bitwise or equals with white king side castling, it now should print this big K, because yeah, now it's available. And if you just bitwise or it with well, let's say white queen side castling, it should print big Q. Okay, and castle bitwise or equals with the black king side castling. Okay, castle. Okay, so it seems like the side to move, the enpassant square if available, are getting initialized correctly. So castling rights, if the bit is turned off, it gets to the dash like it was before here. Okay, the board position seems to be quite pretty nice, so it's not a big deal. Well, probably one last task to make sure it works 100% correctly. We can just print all the bitboards. So print bitboard. Well, actually we can do this within the loop. So let's say print all bitboards. So for int piece equals to 0, piece, oh sorry, let's use the encoding spawn piece slash equals then black king and piece plus plus, and I just want to print bitboard and using the piece as an argument here. Okay, hold on a sec, what the hell is this? Okay, something is... Did I miss something? Hold on. Just to make sure that the counter works correctly, so piece should be from 1 to 11. Yeah, so this is piece works correctly. Oh my god, not the piece. What am I doing? The bitboards indexed by the piece. Yeah, otherwise I was just printing the binary representation of the piece encodings, which is not what we need. So we have a black king, black queen, black rooks, black bishops, black knights, black pawns. Okay, so white king, white queen, white bishops, white rooks, white bishops, white knights, and white pawns. Perfect. This is just absolutely fantastic at the moment. So just like I've been showing you this, guys, within our board variable definition video, that the previous one. So we had all these bitboards been mapped together into this sort of a chessboard. This is exactly what we have here already. So I did manually initialize the bitboards for every single piece type, and then just map them all together in order to see this like chessboard representation with all the pieces on its places. And one last thing before we finish, I just want to interrupt the user input here, compiler run this again, and I just want to open this in, sorry, not in terminal, just want to open the Windows version of it. So view folder and this one, just to make sure it works the same way on Windows. Okay, so we got our bitboards. Oh my god, I can't scroll even. I can't even scroll. Okay, this is unfortunate stuff. Now it just disappears. Okay, so actually let's try it again like this. So I only need to have a look at how the chessboard looks like. Bitboards are represented the same regardless of operating system. Okay, so we got this ASCII character representation for on Windows here, which is quite pretty nice, and all the board variable states. So, all the board state variables are here as well, and indentations are correct. Yeah, so now I'm pretty satisfied. Well, okay guys, so this is it for this video. Thanks for watching. I really appreciate your time and efforts taken into following this series, trying to dig into it, understanding what's going on here. Really appreciate that. So the next video we're going to be implementing the parse FEN function that would be transforming the so-called FEN string, which represents the board position, in using the ASCII characters and some specific encodings. We would be converting that string into the current board position, bearing in mind the position itself, to initialize the bitboards not manually like I've been doing here, but using the automated parse FEN function, and also automatically assigning the site to move variable in peasant square if available, and assigning the castling rights. So that's kind of the plan for the next part. And this is it for this part. So thanks for watching. Until the next video, and take care.